titrate sulfuric acid with sodium hydroxide today. First thing we're going to do is prep up the burette. This long skinny glass tube is a burette and we need to clean it. Also, this piece right here is a stopcock and you want to make sure the stopcock is close. It is funny lap. So make sure it's parallel with the bench top because when it's like this, it's open and all of your solution will just flow through. So make sure that the stopcock is in a closed position. The first thing you do is 2 distilled water washes, and those I already did for you. It saves some time. So you would pour in about 5 mils of distilled water and let it run through the tip by opening and closing the stopcock a little bit, and then you can swirl it out, and I'll show you that technique. But the 2 distilled water washes they've been done already. So the next thing we're ready to do is to rinse the burette with your titrant. Your titrant is the solution that you're putting into the burette, and today it's going to be sodium hydroxide with a concentration of 1 molar. So again, make sure that the stopcock is closed, otherwise it's all going to pour through. And when I pour it, I've got the burette off of the clamp, and I'll just pour in about 5 mils. Now, if you're not a good pourer, you want to do it over the sink because otherwise it's going to be all over the floor. And I'm just going to pour in a little bit of sodium hydroxide here. I'm going to go over to the sink, or you can use your waste beaker. That might be easier for you. And just open and close the stopcock. Again, you don't want any air bubbles in there. You can do it a few times, and then over the sink, you'll want to just roll the burette. Let me move this out of the way. You'll want to roll the burette so that you can coat it, and this is what you saw in the video. And again, the concentration's only a molar. Most of you will wear, actually all of you should wear gloves because you don't want to get it on your hands, although it's not terribly concentrated. And this way I've just coated the whole burette, and you can then just let it go out the tip and hold it down into the sink because you don't want it to splash on you. You all have plenty of paper towels on hand, and this way you won't get it all over the place. And here's my second rinse. These are the 2 rinses that you will need to do. Again, the 2 distilled water rinses are done. And just make sure the tip is closed. Otherwise, you're going to wind up just spilling it all over the floors. You should all have closed-toed shoes on. If you don't, you probably don't want to be the one holding the burette because you don't want to pour this out on your toes. And again, put it through the tip and then just roll it. I'm going to hold this high so you can see, but clearly yours would be closer to the sink. And you're just coating it. And if it pours out the top end, it's fine. It doesn't matter. That looks pretty good. I'm going to let it flow out. Probably going to leave a little bit here. And now what I'm going to do is I'm going to fill the burette past the 0 mark. So this will just take a few minutes. And again, keep an eye on it because it is a narrow tube. It will shoot up quickly and you don't want to pour it all over your hands. And you should have more than enough sodium hydroxide. I gave you all about 80 mils to get started. So I'm past that 0 mark. And now what I'm going to do is I'm going to put this in the burette clamp with the numbers facing toward me. I want the tip to be within the waste beaker so that it doesn't splash. Now I usually get my eye level up there by going up on a bench. She had said, well, you could have it lower than the bench top. It probably is a better way to do it, but again, I don't like them hanging off the edge because it's very easy to knock it right off the table. So I'm going to get my eye level here. And again, I like to use these green squares. Maybe you can see it there. Here's the 0. I want the bottom of the meniscus at the line of the 0 marking. And you will need to play with the stopcock a little bit to get a good feel in regard to flow. So that would be a very slow flow, a little bit faster. And I want the top of the 0 mark at, can you see from there? All right, then I'm going to do it this way so I set it properly. I've got the top of the 0. I'm sorry, I've got the bottom of the meniscus right at the 0 mark. And so I've got an initial reading of 0.00 mils. You've learned a lot about sig figs this year, and it's really important that you apply what you learned here. If you look at the burette, you've got a 23 and a 24 line there, and you've got additional lines in between representing 0.1. So you can see to the 10th place. You're recording to the 100th place. Now in regard to recording with a burette, that 100th place is either a 0 or a 5. So if it's spot on the line, it'll be a 0. If it's in between the two lines, it'll be a 0.5. So my initial reading is 0.00. And when you go to fill out the table here, I'll show you in a minute how much acid you are adding. And that's going to be 10.00 mils, provided that you pipette properly. We'll talk about the color in just a minute. The initial volume of base, the base is the titrant. That's what you have in the burette now. The initial volume is 0.00 mils, and you don't actually have to write mils again unless you want to, because the designation has been made clear here. So we have an initial volume of sodium hydroxide of 0.00 mils. You're recording to the 100th place because you can read to the 10th. And then we're going to get the acid set up. So the acid is going to be the analyte. That's going to have a yellow label today. That is sulfuric acid. And we're going to put 10 mils in here. And to dispense the 10 mils, I like to use a pipette or a burette. I didn't really want to set up two burettes for you. So we're going to go ahead and use a pipette, and it'll be good for you because this will be your opportunity to learn how to pipette because you probably haven't done it. There are different types of pipette guns that you can use. This is a very advanced one that I really like when I'm aliquoting a lot of solutions out at one time. For your purposes, you can use a pipette bulb. To use it, you're going to squeeze it. This pipette was just placed back in the wrapper because it was open but not used. And you're going to put the pipette bulb onto the pipette. Make sure the numbers are facing you so that you can read them. And you want to put 10 mils of acid into the Erlenmeyer flask. Now, I didn't give you the acid yet because I didn't want to take the chance that you confuse the two. You have a squeezed bulb, and then you've got an up arrow and a down arrow. So up arrow sucks the solution up, and the down arrow ejects the solution out. So you're going to put the tip into the acid, and then you'll press the up arrow, and you will see the solution rise up the pipette. I go past the 0, I pull the tip out, and now I want the bottom of the meniscus to be at the 0 mark. So I'm going to press the down arrow slowly. Don't want any bubbles. And I want the bottom of the meniscus to be at the 0 mark. And again, the graduations are to the 10th, so you'll record to the 100th. Once I'm in here, I press the down arrow, and this pipette is to deliver. So that will dispense 10 mils. And it's probably easiest for you to just put this here so it's not all over the place. And I have 10 mils of acid in my Erlenmeyer flask. I'm now going to add an indicator. The indicator we're going to use is phenolphthalein. Phenolphthalein is clear in acid. I'm going to add 2 drops. It's clear in acid, so you wouldn't know it was in there. However, if you don't add it, you're not going to get an endpoint, which is a change in color. So I've got 10 mils of sulfuric acid, to which I added 2 mils of phenolphthalein, and I'm now ready to do my titration. I'm going to pull the waste beaker out. I'm going to titrate into the Erlenmeyer flask. You may need to play with your assembly a little bit. You want the tip to be within the flask so it doesn't splash. And now I'm ready to start my titration. I'm going to pull this toward me because I don't want it to be awkward when I titrate. Now, I'm very ambidextrous, so I can do it both ways. I think you would probably, if you're righty, prefer to swirl with your right hand and operate the stopcock with your left hand. You may prefer it the other way. I'm going to swing it around, which will allow you to see the numbers, but it also puts this on the correct side. You should be able to titrate yourself. Today you may prefer 2 hands on deck because it might be a little bit easier for you, but one of the things they require, for example, in ACE chemistry and also when you take college chemistry in college, is that you can titrate on your own. So it's a skill you would definitely want to learn. So I'm going to add the base to the acid. I want to neutralize it. When I have equivalent amounts of acid and base in moles or millimoles, I will be at the equivalence point. I'll be able to see that endpoint with the change in color. So the other thing you may want to do is you may want to have a white sheet of paper underneath your titration, and I've got a plethora up here, so you're welcome to take, but that will allow you to see it a little clearer. And now I'm going to start to titrate. And what you'll see initially, like if you just start adding it very quickly, see those pink pockets? Can you see? See the pink pockets? But as you swirl it, they disappear. And you swirl it continuously as you titrate so that the base you're adding reacts with all of the acid in the Erlenmeyer flask, not just small regions of it. So as you titrate, you want to get a good feel on the stopcock so the flow is consistent. You don't want it too fast, you don't want it too slow. If it's too fast, you're going to miss the end point. If it's too slow, it's going to take forever. And you can see, if you don't swirl it, you get those pockets. So you want to swirl throughout. And off mine, you're going to get a feel of what the volume should be, and that will allow you to cheat a little bit and add quickly initially and then slow it down when you get close to the end point. So you're looking for the faintest color of pink, and you want it to persist for at least 30 seconds. And it takes patience. So I'm looking for the faintest color of pink that remains for 30 seconds. And if when you do the titration you don't get any pink at all from the get-go, that means that you forgot the indicator. Because phenolphthalein is clear in acid, pink in base. We're not quite there. I just want to see how much solution I've added. Got to be super close. So again, just make sure you have a good feel on this, because you really want to go drop by drop now. I know it's just going to be like a drop. Can you guys see as the drop's coming? Or is my hand blocking the drop? So 1 drop and you've got it. It's a little darker than I'd like, but I only added 1 drop, so I think it's pretty good. So when you have the end point, you have that pink color, and then this is how you get your volume now of sodium hydroxide. You read the burette, and again, you want the bottom of the meniscus, and you'll read it, and it looks to me that I am at 16.70 mils. So that would be the final volume that I record here, 16.75. Oops, I lost my one. Let me just double check that because the reading is very important. I'm going to take that back, 16.65 mils. 16.65 mils. So the total volume of sodium hydroxide here would be the final minus the initial is 16.65 mils. The color of the solution before the titration was clear, and the color of solution after the titration, or let's say color of solution at the end point, is pink. And so that's one trial, and now that we ran one titration, you'll be able to guesstimate a volume that you should be in. So you probably can add the first 14 mils pretty quickly and not have to go the drop by drop to get it going. But again, make sure you have a good feel on that stopcock, because if you jerk it or if you just let it run through, you're going to miss the end point. So 16.65 mils is my final volume of sodium hydroxide, and here you'll actually run 2 titrations and take the average, and the average volume is what you will be putting here, and then you know that you would get the millimoles of the sodium hydroxide, the stoichiometry to get the millimoles of the sulfuric acid, and then you can divide by the volume to get the concentration of the sulfuric acid, which is the goal. The other thing I want to mention before I let you go is you're going to do the second trial now. You'll have the same volume of acid because you're going to put 10 mils in, again using the pipette. The initial volume of sodium hydroxide here, you had a final volume of 16.65. I would drain into the waste until the next whole number. So I would be starting here at 17. You don't want to fill it back up past the 0. That's a waste of solution. So drain to the 17 mil mark, and you'll have 17 mils here. You'll have your final volume. You'll subtract the 2 to get that volume, and then you can get the average volume by averaging these together, dividing by 2 if adding and dividing by 2 if you've only run 2 trials, and that'll be your average volume right here. And that's the volume that you'll configure right into here to multiply by 1. Do the stoichiometry. It's not 1-to-1. And then you'll divide by the volume to get the concentration of sulfuric acid. Titration is much harder than it looks. Some of you will pick up on it very quickly. Others will definitely struggle. That's why you're here, to learn. So just take your time doing it. Now, whoever works here is lucky because you are set to go. You probably will want to go back past the 0. But I do want to show you that right now you have equivalent amounts. I'm going to add a drop of the acid, and you go back to clear. So now you have a little more acid than you do base. And if I added 1 drop here, I would go back to pink. And that's called back titration. It's very cool. but it shows that the titration was right on the money because it took 1 drop of acid to back titrate off. And again, you can continue to just go back and forth with this. If I add 1 drop, ready? You're right back where you were. So it's all very fun. It takes a lot of practice. You will need to prep up your burettes, which will take you a little time. You don't have to do the 2 distilled water washes because we've already done them. You will need to prep up your burette with the sodium hydroxide just as I showed you, and it's also written in the procedure. Other than that, I think you will enjoy the lab tremendously. The papers are in your containers, and the labs are also in the manuals. Any questions? So the lab we are doing, or you will be doing in a few minutes, again, is a titration of sulfuric acid with sodium hydroxide. The concentration of sodium hydroxide is given at 1.00 molar. The volume of the sodium hydroxide you have read from the burette, and I'd like to go into that a little bit more. That volume will be the average of the 2 from your 2 trials. The sulfuric acid, you used a volume of 10.00 mils. Make sure you're recording to the 100th place because you can read to the 10th place. And your sulfuric acid is the analyte that you put into the Erlenmeyer flask. You'll be calculating the concentration of the sulfuric acid. The actual concentration is actually 0.720 molar, so you'll be able to calculate your percent error. In regard to reading the burette, perhaps this diagram will help you a little bit more. It was too difficult to show off the burette directly. For example, shown here is partial of the burette. You can read to the 10th place, 16.1, 2, 3, etc., 16.5, 16.6, 16.7. The bottom of the meniscus is right between the 2 lines, so this is going to be read as 16.65 mils. Again, you can read to the 10th, you record to the 100th place, and that last place will be a 0 or a 5 when using a burette. And so that's how you'll read it. From the 2 readings that you make, you'll be able to determine the average volume of titrant, in this case the base that you used. Once you complete the first titration, you can drain to the next whole number and do your initial volume from 17.0 mils to where you get it. You subtract the 2 to get the volume of the base that you have used in the titration. In regard to the calculation, this is as we did in class. You'll have the average volume right here. You'll multiply that times the concentration to get the millimoles of the sodium hydroxide. Using stoichiometry, you'll get the millimoles of the sulfuric acid, and then you'll divide it by the volume to get the molarity. And that's one main goal of the lab, to determine the concentration of the acid, in this case, sulfuric acid. You'll then determine your percent error to see how good of a job you've done. Enjoy the lab. It's really very fun. Be safe. Again, you must wear goggles. If you need any help, please ask.